I did my video project on the spatial allocation of attention in an interactive environment. This study was done by Catherine Wood and Daniel Simmons not too long ago. Here is a short summary of this study about inattentional blindness. Researchers say that it can be a result from a lack of attention that is not associated with vision deficits or defects, meaning an individual fails to perceive an unexpected stimulus in plain sight. When it becomes impossible to attend to all the stimuli in a given situation, a temporary blindness effect can occur as individuals fail to see the unexpected object and often see the most noticeable objects or stimuli. In this study, researchers used an interactive game where subjects moved through a changing environment where they were instructed to avoid hazards. Results show that subjects are most likely to notice unexpected objects in areas with the greatest risk of contact with a hazard and less likely to notice the same object when a hazard was not presented. One interesting fact is spatial allocation of attention conforms to the demands of the environment. Another fact is from the results of the static objects. They reveal a clear pattern in the spatial allocation of attention in response to the environment, but unexpected moving objects show little, if any, role in noticing other movement outside of relevancy. Here are general methods for experiments 4 and 5, which are going to be for the remainder of this video. The methods for this experiment involve subjects moving their avatar while objects like other cars and pedestrians were in frame. Every object had their own range of motion and their speed varied. The subject's motive was to move from one side of the map to the other 10 times to pick up seeds and deposit them to the other side. While this was happening, a sudden onset of unexpected objects would come across the screen. The main question for these experiments was whether or not the subject noticed the unexpected moving objects. In experiment 4, the methods were just the same, except the objects moved at a specific time and moved horizontally and vertically. In experiment 5, it is exactly the same as 4, except they only had to travel across the map 8 times instead of 10. Here is a table that shows the rates of impact on noticing objects traveling in and out of relevant areas for both experiments 4 and experiment 5. Here is a figure that represents subjects' ability to only recognize the unexpected object if it was both near and in front of them. If you look at all of the other ones, they're not nearly as high as they are when they are near or in front. Why is this important? Well, when a task requires us to focus our attention on a particular region of space, we appear to ignore or filter out task irrelevant areas. Inattentional blindness methods are especially well suited to studying the effects of proximity to the focus of attention. Because the critical objects appear unexpectedly, subjects have no reason to divert attention from their primary task or to attend to or ignore other objects they might not otherwise. This can explain the amount of attention drivers put on the road in relation to how much attention they don't give any other content in their environment. This shows how drivers give most of their attention to the middle of the road, whereas passengers look at everything and are more attentive. Here are some interesting details. The results show the distribution of attention based on areas with high risk or hazards. The results also show that people pay less attention to areas that are inaccessible and pose no threat to their actions. But how well does this relate to every person? Here are some limitations and problems that I noticed while reading. The role of context and task is left as an open question. This also limits the generalizability and where this can be applied to rather than driving or walking somewhere. Some questions are, can this be applicable in a real life setting besides being in a lab or online testing setting for a video game? And can this be applied to every individual? What about individuals with autism or any other mental disability? A general discussion. In this experiment, subjects gave their attention to the task, ongoing actions, and environment. They did not use any form of strategy on searching for the unexpected object. There was no information on where to direct any attention. Their goal was simple: cross the street without getting hit by any hazards. This subject did not find results that were significant with spatial allocation in response to environment. This could leave room for future studies that, such as what happens to a person's attention when being told where to focus and where that person's attention actually is in regards to spatial allocation in response to their environment. If this research could be induced in a real life naturalistic setting rather than a lab based in person video game, there could be real world implications. I believe that these findings could make strides into helping people better their awareness to unexpected objects that could potentially be hazardous. If this was to happen, then this research could be applied to anyone's daily activities. Here are my works cited. Thank you for watching.